instantaneous rate. Part 2. We talked about instantaneous rate at the beginning of the year. Remember that first test? We actually had a question about how fast the diver was moving when he hit the water? Kinda? Okay, remember that we did that?
Yeah.
Okay, now we're going to do a different version of instantaneous rate. Talk about a little more depth. And for this, I need to punch someone in the face. Any volunteers?
I think you'd have much more fun punching me.
All right, Adina, come on up here. Keep your back to the camera. And Connor, can you do me a favor and make sure the camera stays on this? Maybe pull it back a little bit for that. Keep it on your desk for this one. Okay, here's what I'm going to do. I'm going to move my fist twice in front of Adina. Okay? And we're going to discuss the differences between the 2 times I move my fist. Are you ready?
I don't really can't really see it.
It's okay. Oh, it should be behind her. It should be fine. Okay. You can't see over there? All right, hang on a second. All right, this is more important actually right now. Okay, so, are you ready? Move my fist the first time. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi. All right, hold that in your mind what I just did. Moved about 30 inches, counted about 6 seconds. Okay, now I'm going to do it again. I'll do the exact same thing. I'm going to move my fist 30 inches in about 6 seconds. You ready? 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi. Okay?
I like that.
Were there any differences between those 2?
Yeah.
She's completely unharmed. I missed. She moved perfectly,
You can't
didn't
show
she?
your face.
All right, have a seat now. Give Adina back the camera. Okay, now we're going to graph those 2 very different experience. Even though I did the same thing 2 times. Think about it. All I did both times was move my fist 30 inches in 6 seconds. But the graphs would look very different. Okay? Punch 1. First time. I need to drop. This is not high def. I need to make these bigger today. Punch 1. At home.
Yeah, I thought it looked different. I was like,
30 inches, 6 seconds. I started at 0, 0. I wound up at the point 6:30, and I went there pretty steadily. Okay? What's the slope of this line?
1. 1.
6:30.
No, the units don't work. Close. It's change in y over change in x.
So 36.
36, which reduces to
5.
5.
Wow.
The slope was 30 inches over 5 seconds.
6.
Whoops, over 6 seconds, thank you. Which is 5 inches per second. Okay, a slope between 2 points always describes an average change. Maybe in Algebra 1 your teacher even said average rate of change every once in a while for slope.
Yeah.
When we talked about the difference quotient earlier this year, I know we talked about average rate of change and smaller intervals looking for instant rate of change. We took guesses at what it is. In this case, if you're moving steadily, okay, if you're graphing change in distance over change in time and you're moving steadily, what's the difference between the average and the instantaneous rate of change? None. I'm moving at 5 inches per second, and if Adina had put her chin out, or I had really been going to hit her on that one, I would have connected at 5 inches per second. At the instant of contact, it would have been 5 inches per second of speed. Not a lot to worry about. Okay? So, the average speed is 5 inches per second. At any second along this point, at any instant you can imagine, the instantaneous speed is also 5 inches per second. Okay? That's punch 1. Now we're going to compare this to punch 2. This will take a little more thought and a little more math.
Ugh, great.
Do punch 2 over here.
Wouldn't that just be like one of these, like, okay, like that?
It's going to be a piecewise function, definitely.
That's what I meant.
Yes, I thought you were drawing the bracket.
You just erased my question. Never mind.
Okay. Punch 2. My lovely straight graphs. Once again, 30 inches of motion, 6 seconds of time. Start at 0, 0. Let's see, for this one, I want to actually, a little more interested in what happened along the way. 2, 3, 4, 5, 6. Okay. First, nothing was happening. My fist did not move and remained at 0 inches per second for 4 seconds. One year I actually tried to time this, and I figured out that it was somewhere around 1/10 of a second later
But we don't care.
that my fist, we care. We're going to use this as an assumption.
Sorry.
If it were physics, we'd care more carefully about how I measured it. But for now, we're just going to say 1/10 of a second later, I was up here at the point 4.1 seconds, 30 inches. From there, not a lot happened until we got to 6 seconds. Now, when you're throwing a punch and you're really trying to hit somebody, you're trying to go faster and faster every part of the punch. You're trying to accelerate. And if you have to approximate an acceleration from a stop, a parabola is a good start. It's a good guess. Works for gravity, but we're just going to guess that I was using a parabola. That's what we got. Yes?
But that would, okay, like, I mean, I could be wrong, but after you started moving your fist, it's not just, like, in the same spot. Like, it's not a straight line from 4-1 to 6.
Boom. That's why I just said we're going to use a parabola.
Well, no, but you already drew a straight line up there.
Oh, that's after I was done.
But
It only moved for 1/10 of a second, then I just held my fist there. This doesn't represent motion. This represents staying still at 30 seconds.
Oh, just kidding.
So this is my 1, 2, 3, 4, 5, 6. The 5, 6 is just the fist just sitting there. Okay? So yeah, that doesn't represent motion. That's staying at 30 inches. So we're going to say there's a parabola somewhere that connects that. Any idea how we can find the equation for that parabola?
That thing that we
Ask
just did.
your mom.
Ask your mom. That thing we just did. That might work.
Sure, that can work.
Derivatives.
Yeah, what he
Nope,
said.
not derivatives. Derivatives won't help find this.
We
Is
could,
there
all
some
I
equation
know.
for instantaneous rate?
Well, remember we
Try to
did
find a slope.
remember our function review at the very beginning of the year?
No, I really don't.
Well, that would be a problem here. Okay, remember this is y equals a x minus k squared plus h.
Oh, that annoying thing.
Remember
oh,
that?
No, that one's not as annoying as the other thing.
Okay, no, that's not as annoying. This is, now, this part's pretty easy. This is the vertex, okay? My vertex is at 4, 0. So this is y equals a x minus 4 squared plus 0. Do we need to worry about the 0?
No.
No, but we need to find a. So to find a, what we're going to have to do is plug in a y and an x. And if we use 4, 0, we'll get 0 equals 0, so that's a problem.
Top one.
So we're going to have to use the top one. Very good. So 30 equals a times 4.1 minus 4 squared. 30 equals a times 0.1 squared. 30 equals a times 1/10 squared. 30 equals a over 100. 3,000 equals a. So we're looking at the parabola y equals 3,000 x minus 4 squared.
Why did you change it to a fraction?